6. It's still, I'm going to see how the lecture goes at this point, because we were already behind even if I hadn't gotten 6, so the dates are just kind of up in the air. My tentative was over next weekend. This was the calendar up to this point. I was hoping this weekend that this week we could, today we can just kind of knock out R6, R7, finish R8, and then probably have still some time on the 20th for that. But I'll share this once I see how in the world lecturing is going to go, because I'm interested myself. All right. So R6 is, and this is R6 and R7 are together here. R6 and R7, R6 is getting into complex numbers, and then R7 is applications. I just started the recording. Yes. So complex numbers. This is our introduction to them. And people always ask me, why do we have these? What's the point? Okay, the reason we have these is because they answer the question that we're asking. All right, what number, if you ask me to find the number that if I square it, I get 1. All right, well, obviously 1 works. That's X, right? The negative 1 works as well, doesn't it? Yeah, that works too. So when I say, so if I switch that to ask you, when is this true? All right, when is x squared plus 1 equals 0? Well, you know that if you square a number, comes out positive, positive plus a positive can't be 0. And what I say to you is, nay, that is not true. Not every number multiplied by itself gives me a positive number. And that's what this is. Imaginary numbers are solutions to quadratics that we have. Something times itself plus 1 equals 0. Everything you run into up to this point, anything times itself ends up being a positive number. That's not what happens here. Now we have I. So I is the square root of -1, which means I squared is -1. And I like the notation from this book. You can see it both ways. If b is a positive real number, then the square root of -b is equal to I times the square root of b. What that means is if I give you the square root of -3, what's really going on there is I'm going to simplify this into -1 times 3 under the radical. And if I have the square root of products, I can rewrite that as the product of square roots. And I know that the square root of -1 is I. And the square root of 3 is the square root of 3. Can't do anything else with that. Okay, so that's just that's to make a long story unbearable. This is what's going on here. Whenever you see this, the negative pop out and become I, it's because what we're doing is technically we're factoring out a -1 and then saying the square root of -1 is I. Okay, so when do they come up? They come up in questions like this. I showed you an example of there on the top right, but if I get a quadratic such as x squared plus x is equal to -12 and I'm asked to solve it, what happens? Well, first, quadratic. And remember, solve a quadratic, I'm going to get everything on one side, see if I can factor it. Two numbers that multiply to 12 and add to 1. You already know we're out of luck there. So we have to use the quadratic formula. Quadratic formula says x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And what am I going to run into? I'm going to get 1 minus 4 times 1 is 4. 4 times 12 is 48. And then at any other point, this is where we would all start to freak out and say, that's not real, it can't be. You know, ghosts aren't real, imaginaries aren't real. Because what happens? 1 minus 48 is under the root. And there's that pesky negative under the even root. Okay. So when that pops up, the way we handle it is we say that's square root of -1 is I, and then we continue the problem. But I'm going to ask this question on another page. So this is what we're after. What I want you to notice here is something under in the quadratic equation. What's under the radical there is called the discriminant. And the discriminant, if you are trying to remember your quadratic equation, what's under the root is b squared minus 4ac. Now think about this for a second. Everything you've done up to this point has come out, whatever's under here comes out positive, everything's fine, right? As long as that's positive, you end up with 2 real roots, and they are unique, they're not repeated. No. 6 and 7 are due, it'd be next Tuesday. Yeah, next Tuesday. No, since I'm doing R6 today, I'm allowed to push it too. But if you're done with it, excellent work. All right. So 2 real roots or 2 real solutions. Okay. If the discriminant is 0, that means you have a repeated root. So you have 1 real repeated root. And I'm just going to root and solution, same thing. And now what we're doing is introducing the situation where what's under the radical is negative. And in this case, you're going to get 2 complex solutions. All right, so the discriminant, just the discriminant itself, and when I say that, opposite of b plus or minus square root b squared minus 4ac, don't know why I'm saying it, over 2a. The discriminant, what's under that root, that's the controlling part, correct? Because in order to have a square root of -1, I need a square root. In order to have a negative, I need whatever's under the root to come out negative. So whenever this happens, you know you're looking at either 2 unique real solutions, 1 repeated root, or the other. So let's just get our beaks wet here. Simplify these complex numbers. Square root of -9. I'm not going to go into the detail I did above. The rule says if there's a negative out front, if I'm taking the square root of a negative real number, then I can just take that negative out, which is really, just like I said, it's you factor out a -1, the square root of -1 is I. Continue work though, because you're not done. The square root of 9 is 3. I don't have to consider positive and negative because I didn't take the square root of 2 sides of an equation, right? This is just one side. Whenever you write a complex number, unless you've got a root involved, the I typically goes at the end. square root of 6, square root of negative 16. Now you're probably already ahead of me here. All right, square root of 16. Because again, what I love to do is try to do the problem in pieces. Pay attention to the new part. The new part of this is the negatives under the root. Okay, well, if a negative is under the root, if this is a negative number, I'm taking the square root of it. I can just pop it out. Pop out that negative is the square root of negative 1, which is I. And now this is an old problem, right? Anytime we get a chance to do that, anytime we can make it look like something we used to do or we have done in the past, that's great. The last one here is not meant to be as tricky as it may seem. Again, you had the square root of a fraction. People start to freak out with fractions. Slow your roll. Hold on. I have a negative at the root of something negative. So the first step is going to be take that out. Okay. And now you can tackle this one two ways. Some of you may know what fraction itself gives me 1 over 16, or because of the rules of radicals, the square root of the quotient is the same thing as the quotient of the square roots, so I can actually split that. And the I will go over here to the right, not because it's wrong if it's on the left, it's just formatting. And square root of 1 is 1, square root of 4, I'm getting ahead of myself, square root of 16 is 4, and then there's the I. Okay, and I used to do I's like that. There we go. And people could read them. If you take an engineering class, or if you take an electronics class, physics, anything like that, you're going to find out that lowercase I stands for current. So when you get into those classes, if you need to deal with an imaginary, if you need to deal with I, the square root of negative 1, you'll see it represented as J. So don't be surprised if you see J instead of I in another situation. It does mean the same thing. All right? So, easy peasy, everybody's good. No questions, I'm assuming. I'm not trying to Jedi mind trick you into not asking questions. So let's tackle these last 3. I want you to do them. I'm not going to talk. I'm just going to do them along with you. I want to see what you come up with. And if you get into it and you just stop, right? The first thing, the new thing today, the thing I'm teaching you right now is there's a square root of a negative number. That means I can do this. If you can't go any farther than that, that's okay, because that's the new thing today. All right, so if we start with that concept. In the second one, my negative is on the outside, and then I have the square root of a negative 49. Well, the rule says that I can just take the square root of a negative, that's the same thing as I times the square root of whatever number was under there. So for the first few steps here, I'm not really doing anything except first thing I'm doing is the new step. Okay, let's deal with the 2 on the right and then come back to the one on the left, because the one on the left has some extra math involved. I have the square root of negative I times square root of 49. That negative is not under the root, does not come out. It does not get replaced with a letter. It is there. It is along for the ride. Okay, it is the fly that got into your car when you left the house, and it's just going to buzz around until you get where you're going, or you finally get it out the window. Okay, it's in there. It's coming along with us for the ride. Square root of 49 is 7, and then formatting, the I goes to the end. The only time you'll see me not put I on the end on the right is if I still have a radical, which is what you're going to see on that first one. Okay. Next, same game. I times square root of 9 is 3 times I times square root of 16 is 4. 4 times 3 is 12. I times I is I squared. Okay. Feels like we're done, but we're not quite done. X squared is fine, I squared is not, because remember, I is the square root of -1. Square root of -1 times the square root of -1 is -1, just like the square root of 2 times the square root of 2 is 2. So that means 12 times 1 leaves me -12. You'll never end up with a complex number that has I to any power. It won't have any power at all. It'll just either be there or it won't. It'll be power of 1 or nothing. Okay? So both of those, the one on the right, you'll notice you can multiply numbers, you can multiply complex numbers, and then end up with a real number as the solution or as the result of the product. On the left, let's come back over here. I times square root of 54. For me, is there a perfect square in here? It doesn't jump out at me, right? But I do know this is even. I know 54 is even. So half of 54 is 27. All right, 27 is 3 times 9. So all I'm doing is just writing 54 out in its factors, right? There we go. 9 is a perfect square. Okay, so the square root of 9 is 3. So that 3 comes out. Remember the I came out at the very beginning. And then what's left under here is the 2 times the 3. I'd love to be able to do something else with that, but I can't, right? I don't have a mat, I don't have a pair, I don't have a perfect square. So the 2 times 3 just gets multiplied back together to 6. And there's nothing left to do. So this is that case that you'll see me put the I, it'll go after any constants, any real numbers, but it will not go here on the end. And the reason for that is simply if you put it here, it's really hard to tell if you mean for that I to be under the root or not. It's that one, it's more housekeeping for me than it is proper. But when you see me do that, that's why I'm doing it. All right? Yeah, everybody loves complex numbers. Everybody remembers this fun stuff. Questions? All right, so let's take all the things that we just did and answer the question that we started with. So if I want to deal with that original quadratic, x squared plus x plus 12 equals 0. Again, I added 12 to both sides so that I have a quadratic equal to 0, so that I can either use the quadratic equation or I can factor to get two things multiplied to give me 0. This doesn't work in terms of factoring. I can't multiply 12 and add to 1. So I have to use the quadratic equation. It says the opposite of b, which is -1 plus or minus. We've already done the work here. So I'm just going to go ahead and write it. Okay, and then we'll just make a little note here. See last page for work. What am I going to do now? Well, what I'm going to do is the same thing I've been doing as I've been dealing with the square roots of negatives. I'm going to square root of -47 is the same thing as I times the square root of 47 over 2. Okay, so what are my solutions? 47 is prime. It doesn't have any factors other than 1 in itself. So what I'm going to do, and you haven't seen me do this before, is I now have a complex number that has a real part and imaginary part. I have addition, subtraction over a single division. If that's the case, I can rewrite this as just 1/2 plus or minus I times the square root of 47 over 2. Okay. This is, again, a formatting thing. Whenever you have a complex number, you write the real part and then the imaginary part. And that's what I've got. And what's this going to do? This is going to split into two because I still have the plus minus going. So I've got negative 1 plus I times the square root of 47 over 2. And I have negative 1 half minus I times the square root of 47 over 2. The only other way that you may see this, and the book I used to teach from was very particular about this, is since that root is in the numerator, it would put the I to the right of the fractional part of the complex number. But again, I'm more so telling you about the reasons I put things where I put them in the fridge, not because there's actually a reason, just because I have my own habits. So the solutions will be written as these pair of solutions. Anybody know what these are for each other? Take a look at the difference. What's the difference between the two solutions here? Everything's the same except for one piece. Right? The only thing that's different between negative 1 half plus square root of 47 over 2 times I, negative 1 half minus the square root of 47 over 2 times I, the only difference there is that sign in the middle. So these turn out to be complex conjugates. Remember that word? Right? Conjugates are just A plus B, A minus B. We multiplied them so that we could get radicals off the denominator. We're going to rerun into them again here. They're complex instead of rational because they have an I in them. That's the only reason. All right, so this is what solutions can look like. The book does a really good job of just trying to remind everybody negative 1 half plus the square root of 47 over 2I is a complex number, not an imaginary number. Okay, imaginary I is the imaginary part. Complex numbers have a real part and an imaginary part. Sometimes the real part is 0 and they're just imaginary. But again, I've done a lot of work this semester on trying to make sure our vocabulary is correct. And the big thing in vocabulary here is imaginary is just referring to the I. Complex is referring to the number as a whole. All right. Now, what's changed here is up until this point, solutions to equations that required this taking the root of an even root of a negative number were not accepted or were not allowed. Now they are allowed. So what that means is when I go to solve things now, what I was doing before is I was solving over the real number system. Now I'm solving over the complex number system. Okay. The complex number system contains the real system. You know, it's one of those squares. All squares are rectangles. Not all rectangles are squares, right? So complex numbers have the form look like this: A plus BI, right? Where A and B are real numbers. Okay, A is the real part. BI is the complex part. Well, if B is 0, if the imaginary part's gone, all I have is that real part. So all the real numbers are part of the complex system. Okay, they're just where the complex portion are 0. Okay. So when we say give me the complex numbers, just understand the reals can be contained in that. So when I'm solving over the complex, that just means I can end up with i's in the answer and it is fine. So let's solve this quadratic. 48 plus m squared is equal to -1. Let's make sure we're still kicking. I know it's been a couple days. Typically, we get everything on one side, but what's missing here is the middle term. And I see an m squared, but I don't see a term that just has m in it. And whenever that happens, that means I might get to use the square root principle. The square root principle says if I have some variable squared is equal to a number, and I want that variable to come out, or I want to solve for that variable, I'm going to take the square root of both sides. Before I wouldn't be allowed to do this, but now I am. Square root of m squared is m. And now be careful here. The square root of negative 49. We still have to pay attention to the positive and negative results of this. All right. Now, finish the math. And we probably don't need to do this one in 2 steps. Square root of negative 49. The negative means an I is coming out. The square root of 49 is 7. So my answer here is 7i. But I've got the positive and the negative solution. So my solution set contains negative 7i and positive 7i. All right. Questions there? All right, in that case, let's go on and deal with our quadratic. This one looks like it would do nicely. Let's get everything on one side so that equal to 0. Does everybody understand? Can everybody give me some hands up? Does everybody understand the difference in the attack on this, on the problem on the right? Why do I get everything on one side for this problem, but I don't do it on the other? Yeah? Yeah? Good. Excellent. It's a quadratic, right? And it has all 3 terms, right? A, B, let's say it another way. A, B, and C are all non-zero. Correct? All right. Okay, so get everything on one side. Set that equals 0 and solve. 2 things that multiply to 156 and adds negative 24. That feels like it should work, but it doesn't, right? So it's not always going to be something super multiply to 1 and add to 75. That's not going to always be the case. This one feels like it should work, but it doesn't. So it doesn't factor, so I need to use quadratic equation. Opposite of b means negative 24, which is 24 plus or minus the square root of 24 squared minus, that is, I was taught a long time ago that the sign of b does not matter at that step. So if you see me skip that part and just write it as positive, the reason is for some reason I'm still trying to save paper from 20 years ago. And I've done this already in my head. And negative 24 times negative 24 gives me positive. And then subtract the product here. And the result of this is negative 48. Okay. Now, that's the discriminant. The discriminant is negative, so that means the solutions to this quadratic are imaginary. Shoot, I just made like a huge long sermon about they're complex and then I say it wrong. All right, so let's deal with it. 24 plus or minus. I have a negative, so I'm going to bring out the I. And then, okay, as long as we remember to bring the I along with us, now this is an old problem. Square root of 48. 48 is 8 times 6. It's also 16 times 3, right? And which means that 16 times 3, 16 is a perfect square. Square root of 16 is 4. And can I do any more with that? And we need to see what in the world just happened there. Right? And now I can't simplify on the right anymore. I'm going to go ahead and split these up and write this as a complex number, a plus bi. So that's 24 over 2 plus or minus 4i times the square root of 3 over 2. Those simplify. 24 divided by 2 is 12 plus or minus 4i times the square root of 3 divided by 2. 4 divided by 2, the 2's divide away, leaving me at 2i times the square root of 3. And now I can write my two solutions because this is a plus and minus. Solutions here. The solutions here are 12 plus 2i times the square root of 3, 12 minus 2i times the square root of 3. All right. So here's that case I told you about before. You can see the I is not all the way on the right-hand side. It's not the last factor that I write for the imaginary part of the complex number. And again, it's specifically because if you put it on the end, it's easy to make it look like it's under the root. So, like I said, housekeeping, but it also helps you, prevents you from getting the wrong answer. And then when you go to type answers into ALEKS, if the I is on the end, if you type square root of 3, then you have to press the right arrow to get out from under the root to then type the I. So I think it just helps altogether. All right. Last one is going to be done on video. Not here. Okay. But it looks like a big old fat mess, but it's not that bad. The key here is not to forget your roots. Don't forget the steps that you took to get here. And I have a quadratic. I have all three terms, A, B, and C are all non-zero. So we get everything to one side. And then I've got a fraction in the middle. I've got a fraction for B. I don't want that. So I have an equation. I have two sides. So I'm going to clear the fractions, and then I'm going to plug right into the quadratic equation. All right. Now, next part of this, U substitution. U substitution says what? Well, I've learned a whole lot, or we've learned a whole lot going through this process about solving quadratic equations. Take a look at the equations down here at the bottom, or down here below. I have x to the fourth minus x squared equals 42. If I get everything on one side, that's going to be minus 42 equals 0. That looks, if I squint my eyes a little bit, that if that were x squared minus x minus 42, we could factor this, right? Everybody would be able to factor that. 7 and 6, and negative 7 and a positive 6 to be specific. And there's my pen. I keep losing it. Minus 42 equals 0, right? If this were just x squared and x and minus 42, I'd have it. Well, I think I can make it look like that, because notice that the power of the leading, or the highest power, is double the next power, right? X to the fourth is x squared squared. Something squared minus something, and I'm just putting in parentheses to draw attention to it. Minus 42 equals 0. So what I'm going to do is I'm going to let u equal x squared. When I do that, I now have u squared minus u minus 42 equals 0. And I just said that, man, I wish it looked like this, because if it did, this factors. Okay. Two things multiply to 0. One of them is 0. U minus 7 is equal to 0. U plus 6 is equal to 0. Solve for u. So u is equal to 7. U is equal to negative 6. And now we're going to resub. U is equal to x squared, which means I'm back in terms of x's. I have found that x squared is equal to 7, or x squared is equal to negative 6. For both of these, my next step is to take the square root of both sides. And as easy as it is to forget, you have to be super duper careful on the left-hand side, because, or excuse me, on the right-hand side of that second one, square root of x is square root of x squared is x, and the square root of 7 is the square root of 7, but I've taken the square root of a real number, so I gotta deal with the plus and the minus. On the right, I'm taking the square root of a complex number, or see, I'm taking the square root of a real number that happens to be negative. It's not complex until I take that root. So x is equal to the positive and negative square root of negative 6. Okay? Neither of these have any perfect square factors. Like negative 6 is 2 times 3. I can, of course, make this a complex number by bringing that I out. Okay. And so what do I have now? I have solutions. But instead of having my typical 2 solutions or 1 solution, I have 4. Right? The solutions for this problem include the square root of 7, the negative square root of 7, I times the square root of 6, and negative I times the square root of 6. All 4 of those are solutions. Okay? If you're a pattern seeker, and if you're a human being, that's what your brain does, you may have picked up that this problem has 4 solutions. And if you look at the beginnings of the problem, the degree of the original polynomial is 4th degree. 4 degrees, 4 solutions. It's not always going to be the case. The degree of the polynomial and the maximum number of solutions available, they are the same. If I have a quadratic, if I have a square or degree 2 polynomial, it can only have 2 solutions. Can't have more than that. 3rd degree, 3. Think about a linear equation, just 1. Okay? So, questions. Okay, use substitution. On the right, I have another one. This one is more, in my opinion, this one screams use substitution a bit more than the other. The first, that one on the left, you really do have to, you almost have to know what you're doing before you do it. Over here on the right, I have this 2 plus 3 over t squared minus this 2 plus 3 over t, not squared, just to the first power, equals 12. Again, if I could make this look like a quadratic, I could factor it. Then let's let u equal 2 plus 3 over t. If I do that, now I have u squared minus u minus 12 equals 0. Right? Same thing as before. They're one apart. Multiply negative 12, add to negative 1, and minus 4 plus 3. Two things multiply to 0 by zero product principle. One of them is 0. U is equal to 4. U is equal to -3. And then you have to do what we did before. This question was not originally asked about u's, it was asked about t's. So I need to resub the u is equal to 2 plus 3 over t. This one's going to be this is going to involve a little bit more work than the previous to get a final solution, but that's okay. So that means I have 2 plus 3 over t equals 4. 2 plus 3 over t equals -3. Everybody cool with how I went from there to there? Any questions on that? Okay. I've got t in the denominator. I'd really like to solve for it, so I need to get it out of the denominator. The easiest way to do that is clear fractions, but before I go clearing fractions, let's combine like terms. So on the 2 plus 3 over t is equal to 4, I'm going to subtract 2 from both sides. And what's that going to do? I should probably jot that down just because this is can be a bit of a mess if you're not careful. It doesn't affect the 3 over t. 4 minus 2 is 2. And now I'm going to clear the fractions by multiplying both sides by the LCD. Well, the LCD is what? Well, the denominator on the left is t, the denominator on the right is 1. I'm just going to multiply both sides by t. And what's that going to do for me? That's going to give me 3 is equal to 2t, which means t is equal to 3 over 2. On the right, I'm going to do the same as I did before. Get everything with a t on one side, everything without on the other. Subtract 2 from both sides. 3 over t is equal to -3 minus 2 more is -5. Multiply by LCD of t. And now I have 3 is equal to -5t. Finish it up. And t is equal to -3/5. I have checked both of these for solutions just to make sure. So my solutions, the solutions do check, are 3/2 and -3/5. All right. I'm curious as to how you would want to tackle this. If someone wants to talk, you can. If you want to type, you can. If you just want to scribble furiously on paper and then see if it matches up with what we end up with at the end, that's fine too. All right. Ooh, you're right. Yes, I did. I just decided that magic was involved. Thank you. There's the I. There's the I. So there it sits. Good catch, all. Thank you. I knew the brain fog is real. All right. So on the left, I end up with my two solutions. And again, you see my complex solutions are split up. I've written them as the real part plus the imaginary part. On the right, there's such a temptation there to say, I got two things that multiply to negative 34. This must be, this is my ticket out. This is an easy one. Remember though, that only works if I have two things multiply to give me 0. So I cannot do that. So in order to solve this, I'm going to distribute, because that's the only math to be done. Plus 10m is equal to negative 34. It's a quadratic. It's got all 3 terms, so I'm going to put everything on one side. See if it'll factor. Multiply to 34, add to 10. Not going to happen, so quadratic equation gets called in. Opposite of b, plus or minus the square root of b squared minus 4 times a times c. Right off the bat, before we even finish writing it, you can see the discriminant. Because a is -1. A is 1. You can see the discriminant is going to cause exactly what we think should happen. 4 times 34 is bigger than 100. So I'm going to have 100 minus something larger than 100. Means the discriminant's negative, which means my solutions are complex. All right. So what exactly is that? 100 minus 4 times 34, negative 36. So that's negative 10 plus or minus the square root, negative 36 over 2. And that works out so beautifully because square root of the negative means I have an I need to bring out. And then the square root of 36 is 6. So that is plus or minus 6i over 2, which I can split up. And then there's actually division for both of these. A negative 10 divided by 2 is negative 5. 6 divided by 2 is 3. And my solutions are negative 5 plus 3i, negative 5 minus 3i. And there we go. So this one's just, this is a heavy callback on old stuff. This is a heavy callback on dealing with factoring, dealing with being able to manipulate rational expressions, and then being able to write complex numbers. All right, so the last two I'll do for video later. We got 2 more problems to tackle. First one we're going to do is on the left. 3m squared plus 7 is equal to 2. And this one, just a reminder of where we are. We're dealing with the practice page of the notes. So let's go take a look. 3m squared plus 7 equals 2. Now, I didn't want you to start to get into some kind of habit of
doing anything specific. So this practice page has examples of everything we've done, solving for the complex and use substitution. 3m squared plus 7 equals 2 feels super easy. Now, on this one, I don't have all three terms of a quadratic. I have the m squared term, and I have a constant term. I do not have the term with just m to the first power in it. So when I don't have all three, when I have the square term and some real number, I don't get everything on one side like I would if I had all three terms. Instead, everything with the m squared is going to one side, everything without it's going to the other, because we're going to use the square root principle if we can, because it's super duper easy. 7 minus 7 is 0, 2 minus 7 is negative 5. M squared is not by itself because it needs to be divided by 3. I've got m squared is equal to negative 5/3. And we know what happens next. I need to get rid of that square because, again, the goal is to solve for m. Solve for m means get m by itself. Take the square root, but remember when you do that, you have taken, when you take that square root of a real number, it does require you to consider the positive and negative results. So this means m is equal to the positive and negative square root of negative 5/3. Now, there's a couple of things going on here. The first of which is this is complex. There's a negative under the root, so I can bring out the I, and that's going to leave me with root 5/3. Now, I have a radical in the denominator. That is not allowed, right? So I do need to rationalize the denominator. Rationalizing the denominator for us, for this problem, just means I'm going to rewrite the square root of a fraction is the same thing as a fraction of the square roots. And rationalize the denominator means make it so the denominator does not have a radical in it. So I'm going to multiply top and bottom by the square root of 3. Square root of 3 times square root of 3 is 3. And what do I have? I now find that m is the positive and negative I times square root of 5 times the square root of 3 is the square root of 15 over square root of 3 times square root of 3 is 3. This is the positive and negative. There's a lot going on in that answer. So what does my solution set look like? My solution set contains what? It contains root 15 over 3i negative root 15 over 3i. Okay. The I going at the end is just that traditional form for writing a complex number, so that you have that form a plus bi. In this case, our real portion is 0. Last question in the R6, R7 notes under the practice page, we have quantity what in the world is going on in my brain? Quantity, x squared plus 2x closed quantity all squared minus 18 quantity x squared plus 2x closed quantity equals negative 45. If you notice the square, there is no square on this middle term. So if your notes have it different here, there's not supposed to be a square here. And then we're asked to solve this over the complex plane. This doesn't mean the answers have to be complex. It just opens up that opportunity. So what I've got here is, well, it looks like a mess, right? I got a mess, but it does kind of scream a little bit of, I have something squared, I have that same something to the first power, and then I have a constant. So this one actually has that U substitution flavor. Okay, it's really the only line of attack for this problem. We could square everything out, distribute, and solve, but it would just make a mess. It would also bring up a fourth degree polynomial, which we do not want to deal with yet. So we're going to deal with U substitution for now. And what's that going to do? That's going to swap out. X squared plus 2x is now u, so this becomes u squared minus 18u equals negative 45. This is a quadratic. It's got all three terms. Everything's going to the same side. We're going to see if this will factor. So that means add 45 to both sides. And I stared at this and stared at this, and it was like 9 and 5, 9 and 5, 9 and 5, but it doesn't work. But just because 9 and 5 don't work doesn't mean that it's not factorable. It actually is. The numbers just happen to be negative 15 and negative 3. So u minus 15 times u minus 3 equals 0. By the zero product principle, we now see two things multiply to 0. One of them is 0. U minus 15 is 0. Or u minus 3 is 0, which means u is 15, or u is 3. However, we have to resub, right? This problem did not start in the variable u. It started with the variable x. So I need to resub my u substitution. U is x squared plus 2x, which means u equals 15 means x squared plus 2x is equal to 15. Solve this. Subtract 15 from both sides. X squared plus 2x minus 15 equals 0. If you're looking at this and wondering, I've written the minus 15 under the 2x, but these are unlike terms. Right? This one has an x to the first power in it. This is a constant term. I cannot do anything with them. I'm writing it under there just to remind myself to do the subtraction. Just because I write them under does not mean there's actually any subtraction that can be done. This is me just saying subtract 15 from that whole left side. X squared plus 2x minus 15 equals 0. Does this factor? Two things multiply negative 15 add to 2. It does. Okay, and those factors are what? Well, plus 5 and minus 3. And look at this. I get to use my favorite principle twice. Two things oh no, what did I do? Somehow, I've decided that u has come back to play when it is not. No. X's. These are X's. I did all that work to get rid of those u's, and then they just pop back up on me. So by the zero product principle, two things multiply to give me 0, which means one of them is 0. So x plus 5 is equal to 0, or x minus 3 is equal to 0. Solve them both. X is negative 5. X is 3. And now remember, I have an entire other substitution to deal with. So my u is equal to 15 got me down this side. How about my u is 3? Well, if u is 3, that means x squared plus 2x is equal to 3. Again, I have a quadratic. I have all the terms, all three terms of the quadratic, so everything is coming to one side. Minus 3 equals 0. Does this factor? Would I ask if it didn't? I mean, would I? I might. I might also write a u randomly when I don't mean to. Two things multiply to give me 0. By that zero product principle, I know that x plus 3 is 0, or x minus 1 is 0, meaning x is negative 3, x is 1. All of these do check. So I'm now looking at a solution set that contains, and I will take a moment just to put these in order, negative 5, negative 3, 1, and 3. And there you have it. All right, so we got R6 and R7. I had the second page of notes. I had another quadratic here with complex solutions, and I told you that we would knock it out next. So let's do it. We're going to solve negative 5 halves d plus 1 is equal to negative 3d squared. We just kind of talked aloud about this problem and how it is a quadratic. It may not appear to be a quadratic because it's a big old mess, and the really scary part is that fractional coefficient. Nobody likes fractional coefficients. That's not true. I like fractional coefficients, but I am also a fan of many things that my students are not. So let's get everything on one side. It means adding 5 halves d to both sides and subtracting 1 from both sides. Everything on the left is going to go away. Zeros out. And then on the right, I'm going to go in descending order of power, 3d squared plus 5 halves d minus 1. And let's make life super easy and clear the fractions. All right, to clear the fractions, I need the LCD. LCD is what? Well, negative 3d squared has a denominator of 1. 5 halves d has a denominator of 2, and negative 1 has a denominator of 1. Least common denominator here is 2, which means I'm going to multiply both sides by 2, which is great. On the left-hand side, 2 times 0 is 0. 2 times negative 3 is negative 6. 5 halves times 2 is 5. And negative 1 times 2 is negative 2. And now I have a quadratic. My coefficients are what? A is negative 6. B is 5. And C is negative 2. And now we're going to plug this into quadratic equation, remembering just that little aspect that quadratic equation says that the solutions of the quadratic are opposite b plus or minus square root b squared minus 4ac all divided by 2a. Whatever variable you're solving for is what goes on the left-hand side. I just have a d because that's what's after it. Typically you'd see an x there, but let's plug everything in. Opposite of 5 is negative 5 plus or minus the square root. 5 squared is 25. 4 times a is negative 6 times c is negative 2. I haven't seen one of these. All right, and we know we're in the complex portion, so that's kind of what we expect to happen here. I'm just gonna see if it'll let me grab and scoot so I can give myself a little bit more space on the right. So I'm just going to continue with that form, negative 5 plus or minus the square root of 25. Now this is minus, and let's see, what are we subtracting? 4 times negative 6 is negative 24. Negative 24 times negative 2 is positive 48, so that is 25 minus 48 over negative 12. 25 minus 48. What does that do? 25 minus 48 comes out to negative 20. What? Okay. Well, it'd be almost 25. It would almost be 25, but it's not. So I think it's negative 23 here. Over negative 12. I have a negative under the root. This means my answer is complex because that discriminant is negative. And then I can split it. The 23 does not have any factors that are any perfect square factors. So I can, let's get this going to the other side. That's negative 5 divided by negative 12 plus or minus and then square root of 23 divided by negative 12i. And then this splits into, well, let's clean up one more step here. Negative 5 divided by negative 12 is just 5 over 12. So there's the real portion, and then here's the imaginary portion, plus or minus. This is negative square root of 23 over 12, which is going to do something interesting. We haven't run into this before, so let's talk it through. 23 over 12i. What does this do? If I was writing this out, this is a plus minus a negative. Mathematically, what happens here is this becomes a minus plus. It doesn't actually change anything for us, but if you ever have to distribute a negative through a plus minus, that's what happens. So my solution set has 5/12 minus square root of 23 over 12i, 5 over 12 plus the square root of 23 over 12i. Hello everyone, we're going to finish up that R6 and R7 notes. I told you I had the word problem at the end that I said to skip. I got a little ahead of myself, over my skis, whatever you want to say, and this problem got away from me, so we're going to do this little video here to make it make sense. I do want you to notice two things. First off, I have the notation, I have the equation correct now. The initial velocity is 8 times the square root of 5, so that is 8 times the square root of 5 times t. The reason I brought the parenthesis in here is just to draw attention to the fact that t is not hidden under the root. Okay, that if you look at it in your notes, you probably see the t hiding under the root. If the t were under the root, nothing good would happen. So it is not there. The other thing you may notice is I made a small change in notation. Instead of just s over here, you see s of t. And so your notes may say s is equal to, and then I just have everything that's on the left-hand side. Let me talk about that for just a second, because this is what you see in your notes. I've got s of t. This is called function notation, and it's just saying that s is a variable. S in this case is the height, okay? Because we all know height begins with s. That's absolutely wrong. It does not. It's s is actually position, which also doesn't start with s, but you get the idea. It's a physics problem, so we actually have some underlying information here. So this is telling me the position off the ground. So s is the height off the ground. Backdoor reaches after t seconds. Now, the notation, or the s, you notice I'm saying s of t. The reason it's s of t is because I literally have s, the height, in terms of t. Think about what I just said. S in terms of t. Now that just sounds like something someone says in math class and we all ignore, but look at what I've got. S, so here's s, in terms. Remember, terms are separated by pluses and minuses, and terms of t means I have terms, things that are separated by pluses and minuses, with t's in them. Is that what I have on the right-hand side? Absolutely. Negative 16t squared is a term, it has a t in it. 8 times the square root of 5t is a term. So I have s in terms of t, right? All those words, when we say them, they have a meaning. S in terms of t, or s of t. So, but let's get rid of all of this extra fluff, and let's tackle this problem. The first thing you're going to notice is, if you pay attention, if you watch the video that we did in class, first thing was that I had the t under the root for some reason. And the second thing was I'm looking for, I should probably read the question. We're 3 minutes into the video. At the time of printing, the highest vertical leap by a human is 60 inches, held by Kaddour Ziani. For this record-setting jump, Kaddour left the ground with an initial velocity of 8 times the square root of 5 feet per second. How long after leaving the ground would it take Kador to reach his maximum height? So a couple things are going on here. The first one that I did not draw attention to is the units of the problem. So the initial velocity here is in feet per second. Okay? You don't know this yet, but we have this negative 16t squared. This negative 16 is the acceleration due to gravity in feet per second. So feet per second are appearing in here multiple times. This means, and you'd only know this because I'm telling you this, that when I get done, S is two-letter word, Larry. Two-letter word, and you misspelled it. S is in feet. Okay? Maximum height that Kador reaches is 60 inches, so we do have to do a quick little conversion here. 60 inches. I want inches to go away. I want feet to end up. Do you have to do this? No, you don't. But it's always helpful to see the math when it's working. This is dimensional analysis. We're just getting rid of the inches. And 60 times 1 is 60 over 12. These are feet. 60 divided by 12 is 5 feet. So instead of looking for when S is 60, which is what I did in class, we're actually looking for what is T when my function S of T equals 5. All right, so S of T, that's the entire left-hand side of the equation. So what have I done? I have 5. I plug it in for S of T, and then I solve for T. So let's do that. So 5 is equal to negative 16t squared plus 8 times the square root of 5t. This is a quadratic, so what am I going to do? I'm going to get everything on one side. It doesn't look like a quadratic because of that middle, because of the b, because that 8 times the square root of 5, but it is. So everything to one side, right? I got a quadratic, I got all 3 terms, which is why I'm moving everything to one side. Left-hand side has 0 on it, right-hand side. Negative 16t squared plus 8 times the square root of 5t minus 5. Now, let's take stock of what we have because, again, it's just an odd-looking problem. My coefficients are negative 16 for A. B is 8 times the square root of 5. That is just a number. And then C is negative 5. So what do I do with all this? I plug this into the quadratic equation. And the quadratic equation says that T is equal to the opposite of B, which is negative 8 times the square root of 5, plus or minus the square root of B squared, negative 8 times the square root of 5, all squared, minus 4 times A times C. Close that. All divided by 2 times A. Now, what's going to happen here? Negative 8 times the square root of 5 is just negative 8 times the square root of 5. There's nothing to do there. Plus or minus the square root. Now, negative 8 times the square root of 5 squared means negative 8 times the square root of 5 times the square root of 5. Negative 8 times negative 8 is positive 64. The square root of 5 times the square root of 5 is 5. So this is 64 times 5 minus 4 times negative 5 is negative 20. Negative 20 times negative 16 is positive 320. And then the denominator is going to end up with a negative 32. I'm going to scoot to the next Just come down to the next. I'm looking at negative 8 times the square root of 5 plus or minus the square root. 64 times 5 is 320. And something amazing has happened. Okay, whenever we dealt with quadratics up to this point, we've always had that plus minus. That plus minus gives us two answers, correct? Well, in this case, there's nothing over there. 320 minus 320 is 0. Square root of 0 is 0. So all I have is negative 8 times the square root of 5 over negative 32 plus or minus 0. Add 0, subtract 0, nothing changes. So instead of having two answers, I only have one. Negative divided by negative is a positive. Let's write that step out. All right, plus minus 0 just goes away because there's nothing to do. 8 times the square root of 5 over 32. We're going to take that. If you see some reduction here, you're right. 8 and 32 have common 8. So this will reduce to the square root of 5 over 4. But I don't know how many seconds the square root of 5 over 4 is. So I put this into a calculator, and I find that I'm looking at 0.559 seconds. So Kadir reaches his maximum height of 60 inches after 0.559 seconds, or 559 thousandths of a second. All right, last page of R6 and R7. We did this problem in class, but I feel like it got away from me. So I thought I would just toss it in as a little podcast bonus, podcast extra, I don't know, bonus episode. We have our distance, d in feet, required to stop a car that was traveling at a speed v in miles per hour before the brakes were applied. Depends on the amount of friction between the tires on the road and the driver's reaction time. After an incident, a legal team hired an engineering firm to collect data for the stretch of road where the accident occurred. Based on the data, the stopping distance is given by the equation d is equal to 0.05 v squared plus 2.2 v. Part A, determine the distance required to stop a car going 50 miles an hour, and then B, up to what speed to the nearest mile per hour could a motorist be traveling and still have adequate stopping distance to avoid hitting a deer 330 feet away. So I mentioned this in the last one. I'm going to kind of, again, just get you comfortable with the notation. Our equation is d is equal to, well, that is once again d in terms of v, right? On the right hand side, I have all terms of v. So I have 0.05 v squared plus 2.2 v. This setup's going to help a lot. So part A is what's the distance required to stop a car going 50 feet. Well, here's the beauty of function notation. You're telling me the car is going 50 miles an hour. That's the velocity. You're asking me what's the distance when that happens. Guess what that looks like in function notation? Well, I have d at 50. And what do? I plug in 50. Everywhere there's a v. I do some math. I square 50. I multiply by 0.05. That gives me 125. I do 2.2 times 50, which gives me 110. I add those two things together and end up with 235. This is a word problem. So the required distance is 235. What were we traveling in? What was our velocity? Our velocity is in miles per hour and our distance is in feet. All right, so it's feet. Okay, I know it's not even though the velocity was given to us in miles per hour, the distance is given in feet. and that is just from the problem. They tell us distance is in feet and speed is in miles per hour, okay? So they tell us that when I plug in the speed in miles per hour, I'm going to get out distance in feet. So the math is already done for us. Unlike the problem with the vertical leap, where they didn't tell us the output, where they didn't specifically tell us the output unit. So part B, up to what speed to the nearest miles per hour could a motorist be traveling and still have adequate time to avoid hitting a deer 330 feet away? So in part A, they gave us the velocity, asked us to find the distance. Now, what are they doing? They're doing the opposite. They're telling us if I set my equation d of v equal to 330, they want us to find v. All right, so the equation is d of v is equal to 0.05 v squared plus 2.2 times v. One day, I'm going to decide to write t or write 2's with a loop or without a loop. But just today's still not that day. All right, so there's the equation, and they're telling us that the distance that I want to stop in is 330 feet. So that means d of v is 330, not v is 330. That's the grand temptation here. Okay. D of v is 330, right? I'm looking for the v that returns 330. Okay. If I say it one more time, it'll make perfect and total sense, right? No, that's not how math works. All right, this is a quadratic. I have a square term, I have a variable to the first power term, and I have a constant. It's trinomial, so I got all three terms of the quadratic, which means in order to solve it, I'm going to get all the terms on the same side. 0 is equal to 0.05 v squared plus 2.2v minus 330. That is a quadratic. And how do I solve it? Well, leading coefficient's not 1. I could do some work here, but I think just use a quadratic equation. Just go ahead, bite the bullet. There are worse things in the world. I promise you will be fine when you get done with this. Let's again remember what are our coefficients. A here is 0.05, B is 2.2, and C is negative 330. Take those and plug them in. So that means V is equal to the opposite of B plus or minus square root of B squared, which is 2.2 squared, minus 4 times A times C, all divided by 2A. A is 0.05. Now, you've been paying attention in that most recent lecture. We talked about the discriminant and how what's under the root. If what's under the root is negative, my solutions are imaginary. What's under the root better not be negative. This is an application problem, and does that occur? Absolutely not. 2.2 squared, that's minus 4 times 0.05 times negative 330. That multiplication is going to result in a plus, so we're going to jump to the calculator here, because again, we're dealing with a application problem, not a direct math problem, so I can get some decimal answers, and everything's going to be fine. So 2.2 times 2.2 is 4.84, and then I told you this was going to be 4 times 0.05 times negative 330, which is going to give me negative 66. So that's minus negative 66, which is plus 66. All over 2 times 5/100 is 1/10. And finish it up. 4.84 plus 66 is 70.84. Negative 2.2 plus or minus the square root 70.84. This is where it got away from me in class. I forgot to actually then take the square root divided by 0.1. What is the square root of that number? 70.84. Square root is 8.4, and I'm going to call it 2. Yes, I'm rounding heavily here, but again, it's an application problem, so that's okay. So I'm going with negative 2.2 plus or minus 8.42 divided by 0.1. This splits into 2 problems, right? That plus minus means I got 2 answers here. Negative 2.2 minus 8.42 more is going to give me negative 10.62 divided by 0.1. Dividing by 1/10 is just going to move the decimal 1 place to the right. So that's negative 106.2. These are miles per hour. And does your car go negative 106.2? Absolutely not. Application problem, meaning I can't have negative speed, right? When I drive to work, I drive 55 miles an hour. When I drive back home from work, driving the opposite direction, I don't then drive negative 55 miles per hour. So we toss that answer, and we're left with what? Now I have negative 2.2 plus 8.42. So negative 2.2 plus 8.42 is 6.22 divided by 1/10, which is 62.2 miles per hour. Now, does this answer make sense? Well, let's think about what we know from the problem. The problem told us in the last part that if I was driving 50 miles an hour, it's going to take me 235 feet to stop. If I'm traveling faster, do you think it's going to take me farther to stop? Yes. And I am traveling, this is saying to stop in 330 feet. I could be going all the way up to 62.2 miles per hour. Again, not a goal. You don't want to drive 62.2 miles per hour at night because your bright lights can only see far enough ahead of you to stop within 55 miles an hour. That's why that nighttime speed limit, nighttime max speed limit is 55. So if you're driving at night, you get the brights on, you're trying to keep an eye out, you want to be safe, especially it's starting to cool down now. Keep the speed around or below 55 at night. That way you'll be able to react and you'll be able to see something in the road so you don't have a big old bill to pay when you slam into a deer or hit an armadillo or see a possum or whatever else in the world might be on the road where you are.